Thank you, Tejas. Thank you, everyone. Good evening. I'm Abhishek. I'm a product manager with Flutura. I think this is the very right time to talk about corrosion as a whole, because since morning we have been talking about corrosion at times in silos, maybe about the material, maybe about the product that is flowing in there, sometimes about thickness, sometimes about just visual inspection around it. And we were also discussing, there was some prominent colleagues of mine here, they mentioned about integrated systems of around corrosion, integrated systems about emissions. So here I would like to present a holistic picture that we were able to think about, generate and create, considering the fact that we have given around 3 to 4 substantial years from the, I think, starting 2020 on this, discussing with our clients. You could see the likes of Pan American Energy, Hess, Motiva, Pacific, Citco, Shell, and a lot of others. From there, we could create a system, or we could think of a consortium that is not just restricted towards getting the corrosion detected or just understanding that this is my underground pipeline, I need to do some inspection on top of it. There is a whole lot of story that is going around it, and the human story which was missing, we tried to pull it in. So talking with different pipeline inspectors, risk management officers, reliability engineers, then talking with academia, IISc, then different colleges outside India as well as inside India like IITs and others, BITS, Pilanis, we could map. There were a certain elements which were all correlated with corrosion that were coming into play. Now it could be gas leakages, it could be liquid leakage, it could be pressure drops, there could be the product impurities coming into play because of corrosion, there was energy wastage happening around corrosion, there were clogs inside the pipelines, and lot of other elements were coming at places such as there were pipeline curvatures, pipelines which were buried inside. There were pipelines lined up straight for like kilometers and kilometers, 22,000, 30,000 kilometers. There were pipelines which were insulated. There were storage tanks. Okay, all of this all constituted to a list of problems which were rising because or from corrosion. Now, it was not just sufficient to detect corrosion or find like some XYZ point there is corrosion. It's more important to actually fight it. And to fight it, I need to know what is the type of that corrosion, right? I mean, to solve any health issue, I need to know what that health issue is. So, is it pitting corrosion? Is it crevice corrosion, or it is basically top of line corrosion, or is it rising from weld defects like porosity, undercuts, cracks, other elements around it, or has the thickness reduced in a uniform manner or a non-uniform manner? We need to talk about each and every element of it to get to a solution that can actually resolve it. Okay, so this is now we were talking about the problem. To solve this, it was not like I can use one type of sensor or one type of camera to get it done, or one drone or one robot, and I'm done with it. Our colleague today from HPCL, they were talking about robots coming into play for tank inspection and other things. So on these lines, our product would take care of all of this at one single point. So that's why we are calling it a corrosion and emission command center. Be it how big your plant or multiple plants coming around it. So a set of different types of cameras, for example, thermal cameras, as Professor Suresh was telling, giving you an idea of how the camera is, how it's working around it. Boroscopic cameras at places where you cannot enter, where your drone cannot enter. Okay, so then industrial cameras, machine vision cameras, hyperspectral cameras, ground penetrating radar, all coming into play along with drones, static mounts, like they are placed at certain critical locations. For example, where there are weld joints or pipeline joints, I can place a radiographic camera and get continuous images from that place to get a X-ray imaging of that and find out different defects around it. All of this combined with the major element of it is human. Okay, we have experienced corrosion engineers, corrosion institutes, and a lot of corrosion theories around it. All of this had to be codified. codified in a manner that can be retrieved as fast as possible. Because if I take terabytes of data and I just type pitting on web, I'll get list of applications. It's not about that. If I give my KPIs such as the pitting is at a level of XYZ, or it is a level of degradation index of 10, what should I do? So when I put in such commands, I should get all the elements around it. So that is where this product comes into play, taking about the human factors, your experience, collaborative working around it, and creating giving you the prescriptive analytics on what to do with it. So this is the end-to-end this thing. With the advent of time, I'll move directly into our demo. So vision analytics at Flutura is targeting multiple applications such as structural defects, corrosion, weld defects, acid thermal anomalies, metal surface cracks, anything and anything that we have to do with inspections around things. So I can go and talk around for like a couple of hours around this, but this for not to do that, we have created a demo which we are actually releasing it to public very soon, probably in the first week of June. For everyone, it's like a try before you buy it. So for example, there will be a list of more than 50 to 60 problems here that are that will be occurring in your daily journey in your industries. Maybe corrosion is my thing, or corrosion is something that I want to solve today. I can just go into that element. Just a second, we are having a little snag with the internet. So this is something like a no-code system, where you don't need to know AI, you don't need to know how to train a AI signature or anything. You just come here, there will be sample images for you, where you will get to see that this type, on the input, what are the different types of corrosion, what are the different metrics my system is generating, like how degraded that pipe is or how degraded that metal is, what are the different types of corrosion around it, and what is the what is the percentage of each corrosion happening. So if pitting is more, I need to use a different type of inhibitor maybe, something like that. So this is the whole idea behind it, where you come and try your own images. You can upload a set of images. You can try it then and there itself. A better feature on this is, suppose as a reliability engineer, I have a system which can detect, say, crevice corrosion or pitting corrosion. But I also want to detect microbial corrosion. So I can click on refining a system. In next 5 clicks, I'll be able to create an AI system without writing a single line of code. Okay. For some reason, the internet is not working out. So I had a video around here for the same. So once I click on refine, I'll be moving into a system where I can upload my data. All I need to do is upload corrosion images, mark them up in the right place. Once you mark them up, you move ahead. All your images will be enhanced and made suitable for AI generation automatically. No need of coding at all. So this is the world's first industrial AI no-code tool. All the AI tools that are coming up, or computer vision tools that are coming up, they are very generalized for dog detection, cat detection, and everything. So this is where you come up and create your own signatures and be ready in like 5 clicks. So this is where you generate your AI systems. From there, your day-to-day life will be on the lines of what we call as digital assistants. A few examples were shown by my colleague Tejas here. This is another type of digital assistant where you get a complete overview of your entire plant. In that plant, all the inspections that have happened, they might be happening in silos by different teams or as a collaborative systems. Now this can be using any type of camera, any type of sensor, every data coming onto a single data lake where your analysis is at one level. From here, you will get to see all your inspection hotspots. Just a second, again, internet issue. Yeah, you will get to see all your inspection hotspots. Say for particular unit, I want to check it for the inspection happened for my CDU. I will check whatever the different corrosion incidents that have happened there and inspected and taken out. From there, the story doesn't end. It is all about resolving it. So I will get to see a list of all the hotspots that exist. Once I click on any region, I'll see all the corrosion that were in the vicinity. If I want to inspect one particular element, I'll get to see that this at one particular element or one particular joint, which will be geomarked with our digital twins capabilities, you can see that the corrosion has happened and how you can resolve it using a set of comments basically from collaborative systems, like different unit engineers are coming into play and commenting like, this is how it was solved last time, this is how it is solved this time. So it's all about the human experience coming into play, and from there I get all the recommended steps with GenAI's experience. So with the advent of time, I'll hand it over to Accenture to take it to the next presentations. We can our booth is out there, we can definitely discuss it in detail. Thank you, everyone.
So good evening, everyone. Thank you, Abhishek, for that presentation. So now Flutura is part of Accenture, so technically whatever he presented is all about Accenture now. So having said that, while Derek and team is trying to solve the problem at a digital twin level, right, from a physical assets perspective, some of the problem statements